Good morning, SAP Inside Track Bangalore. DJ here. Welcome to this session. I'm just about starting now. I'm just going to go head over to the tweet deck and just make sure. Okay, you should be able to see very shortly. There we go. I'm talking to Sudeep remotely. Can you see me? Let me know in the private chat here on Twitter that you can see me okay. I think we're good though. Brilliant. Okay, so thank you so much for having me on this SAP Inside Track event remotely in Bangalore. I'm so honored to be here. I'm looking forward to the next 30 minutes with you. I hope you have had a great time. Okay, you can see that's great. Okay, I'm going to close that. So as you can see, I'm here for the next half an hour with you. And what I'd like to talk about, as you can see, hopefully on the screen, I'm not a great slide person, so I've been doing something slightly different instead. What you can see on the screen is I want to talk about the next steps in functional programming. We did a session, and Sudeep and Napit have also referred to this in the run-up to this Inside Track. We did a session, didn't we, together at SAP TechEd in Bangalore a couple of months ago, and that seemed to be well received. So this is almost like a next step. It's like a next gentle step beyond that. So what I want to lead you through in the next half hour is just to look at three things. I want to keep it really, really simple. I want to look at currying. I want to explain what currying is, and we'll do all this. I mean, after I've talked about these three different concepts, we're just going to do some live coding. But I want to talk about currying and explain what that is. But basically, this description here I've taken from Wikipedia, and it's pretty accurate. The currying is the act of translating the evaluation of a function that takes multiple arguments into evaluating a sequence of functions, each with a single argument. Now, that's the very strict definition of currying. Basically, put another way, if you've got a function that takes 3 arguments, if you curry that function, it means that you can call that function with fewer than 3 arguments. And what you get back, if you call it with fewer than the total number of arguments it's expecting, what you get back is not the result, because of course, how could it give you back the result? It's not been given all the arguments, but what you get back is another function waiting for the final arguments. Now, the strict version of currying, and we'll see this in a little bit later, is that you give it 1 argument at a time, but we'll talk about that later. So that's currying, and we'll cover currying. Almost like the other side of a coin to currying is partial application. So what I've just described there, giving a function fewer arguments that it is expecting, you could say that is you're partially applying that function. And that's basically what it is. So if you give a function that's expecting 3 arguments and you only give it 2, and then you get back another function waiting for the final argument, you can say you have partially applied in the first call that function with those 2 arguments. Okay, and we'll look at what partial application looks like and feels like in real life in a really simple example. And finally, and this sort of goes alongside this sort of two-sided coin thing, this concept of point-free coding. It's also known as tacit coding. It sounds really posh, but actually all it means is that it's striving to embrace a paradigm where, well, as it says in the definition, where function definitions do not identify the arguments. That's why points, arguments, points, same thing. Do not identify the arguments on which they operate. So basically, when you see point-free coding, you're seeing references to functions and compositions of functions where there's no arguments involved. Okay, no parameter passing. So I've mentioned in the call, in the talk at TechEd, that the code that you write in this sort of paradigm is sort of solid state. It doesn't move, and that's partly it's because you're not supplying any arguments that could change. Okay, Okay, so that is the end of all the slides. They're not really slides. I hope you enjoyed that lolcat and figlet based approach. So what I've got, let me just bring this up here, again, to use something that we've all seen, which is the Northwind data. So I want to keep this as simple as possible. So I'm going to grab the data. These are products here. I'm going to grab the data from the source, and we can get rid of that. And now I'm going to bring up, the only thing we're going to use now, from now on, is the Chrome Developer Tools console. And I've opened this Chrome Developer Tools console in the context of a particular page, and that's the Ramda documentation page. And the reason I've opened it up in the Ramda documentation page is just so we get access to a specific Ramda function, which we'll look at. But you can do this generally, apart from the one function call to the Ramda function that we're going to use. You can do this anywhere, right? I'm just using the Ramda function as a convenience function because we haven't got enough time to sort of dig in a little bit more. Okay, so let's get started, shall we? So this is sort of in three parts. The first part is just getting a feel for the data and starting to look at what we might want to do with that data. So I'm going to define. Oh, let me just clear the console history. And there we go. So we're going to define dot value. So I'm going to grab those products that I've just copy pasted. In fact, let's just make sure we've cleared everything. There we go. We've cleared that now. So we're going to do that again. So products equals that. Okay. So now we've got those products in an array. Okay. We can have a look at that like that, which is great. We can also have a look at it in table form, with a console.table. And you can see here that we've got a number of products, all the different product names, and these products have a category ID. So some products belong to the same category. Chai and Chang belong to the same category. I guess they're sort of teas or something. And also they have different supplier IDs. So Chai and Chang and aniseed syrup are from the same supplier ID number 1, and so on. Okay. So that's really, we can sort of ignore the rest of the different properties here. I'm just going to flip over to TweetDeck to make sure everything's okay. Yeah, I think we're good. Hey, good afternoon. We've got some people on the live stream as well. I guess watching SAP Inside Track Bangalore remotely, Sashin and Mahesh and Phil and Deepayan and Tarun. Hello, and welcome. Okay, so let's go. So what we really want to do, in fact, I'm going to be using this console table quite a lot. So let's use the fact that JavaScript treats functions in a first-class way. We can assign functions to variables, so we can actually say, that now, which is a lot shorter. Okay, which is great. So what we'll do is we'll pick out a product, and we use that as a reference product, and then compare different products to it. So we'll just pick the first one. So let's call it leader product. Leader equals products of 0. Let me just clear this. I'll try and move things up to the top of the screen. I'm guessing that's going to be easy to see if you're looking at a projected monitor. So there's our lead product, and let's have a quick look at it. We can see that it's got product ID 1. It's chai, it's some sort of tea. Therefore, it's in that category ID 1, which is tea category, and it's from supplier 1. Okay, so we want to compare. We want to find other products that sort of compare with this. So let's have a first go, and we're already knowledgeable about using the filter. So let's products.filter, and then we'll just start simple. We'll pass it a function because it's expecting a predicate function that should return true or false. We'll product, and then we can hit enter. We can just carry on typing. Return product.supplier ID is the same as leader.supply ID. Okay, and so that's going to hopefully return us a number of products, and we can see it's returned us 3 products because they've all got the same supplier ID. Okay, so That's fine. But it just feels not quite as nice as we could make it, right? So, it's we're using first-class functions. We're supplying a function to a function call. We're sort of using pre-ES6 syntax, which is fine. We'll change that shortly. But it's sort of hard-coded. It's not really easy to change. It feels a little bit cumbersome. Let's say we wanted to change the comparison to say, well, actually, we want the products in the same category. So we've got to go in and change this, which is, it's not so much typing, but it just feels a little bit brittle because we're going into the function and modifying, the core of what we've been defining, which doesn't feel quite right. We're changing things and could break things. Okay. Well, now we've got, now we're comparing categories, and there's only one other product that's got the same category, which is this Chang product. So that's fine. So, but it still feels a little bit wrong. So what we'll do to sort of make ourselves feel a little bit better is we'll just redefine that first of all using ES6 syntax, because that makes it a little bit neater and maybe a little bit easier to think about. So if we say product, just to sort of get us used to also ES6 function definition syntax, fat arrow syntax, product dot category leader dot category ID. Okay, that's fine. That feels a little bit better. It's a little bit easier sort of to think about, but it's still clunky, right? We've still got to change the innards of that. In fact, let's make it even more easy to think about. Why don't we instead say, what do we call it? Has lead category, and then has lead category, and we'll define that as a function. So I'm just going to copy paste that there like that. Okay, so now we've sort of extracted out that function and put it into a variable called has lead category. So now we can say products.filter has lead, this has lead category. This command completion is great, but it's a bit too much sometimes. And that works for us as well. So it's great because we can sort of now think about our sort of, utility function in a more isolated way. But notice as well that almost like by accident, we're starting to see the use of not partial application, well, we are using partial application, but we're starting to see the use of point-free programming, because basically there's no points here, there's no arguments. We're not really passing to this has lead category, at least, we're not really passing any arguments, okay? We're not passing a product directly. Yeah, the filter mechanism, the filter list mechanism is passing the product. So that's quite nice. But while we're sort of staring at that and just wondering about, this point-free programming, let's start to think about what currying is and what it sort of looks like, because we want to start using currying to improve this situation here. So let's start really simple. Let's say we've got a function that adds numbers together. So let's call add stuff equals A, B, C, A plus B plus C. Okay, so we define a function, add stuff, that takes 3 arguments. It's expecting 3 arguments, and it's going to add them all together. So we can say add stuff 1, 2, 3. It'll give us 6, right? Which is fine. That's all good. But what really is, what if we don't supply all the arguments? What really happens if we try to partially apply this? And partially applying is basically not supplying all the arguments. Add stuff, and we're going to partially apply this and not supply all the arguments. We're going to supply 2 out of the 3 arguments, 1, 2. Now that doesn't really work very well, does it? Okay, it's giving us not a number. Does anybody know why that is? I mean, I can't see the chat, but put in the chat if you know what it is, or just shout out into the room. I won't be able to hear you, but shout out into the room if you know why that is. It doesn't really work well because, of course, what's happening is that it said, well, you've given me the arguments. This is not yet curried, okay? So you can only successfully partially apply a curried function. So in order to think about partial application, we've got to think about currying at the same time. So we'll look at currying now as well. So what's happening is that we're saying, or effectively what's happening is this. 1 plus 2 plus undefined, because the function is completing C, we haven't given a value for, so it's saying, well, it's undefined, and 1 + 2 + undefined is not a number, okay? Which, whether that's good or not, let's not even debate that, okay? So instead, let's curry that add stuff function, okay? So this is why I'm in the Randa documentation, because that uses the Randa library in the background, which gives me access to it here in the dev tools. So let's just bring that definition in again. But what we'll do instead is we will curry that function. And there's a really nice function in the Randa library, R, called curry. And if you curry a function, it will take that function, whatever you pass it. Oh, I need to put a, there we go. Is that right? No, it will take that function that you passed to curry, and what it will do is it will give you back another function, right? But that function is now able to be partially applied. So now we can say add stuff 1, 2, and it's not giving us an error. It's not giving us not a number, because it's not trying to work out what C, the value for the argument C is, and then failing and getting undefined. What it does is doesn't return us the answer. It returns us another function waiting for another argument. So we can say add stuff. Well, why don't we assign the result of calling add stuff, of partially applying add stuff with 1 and 2, assign that to Z, okay, and then we can call Z with 3 and get the answer. Okay, so we've partially applied add stuff, giving it 2 arguments, and we've created another function called Z, we've assigned it to Z, and we call Z with the final argument, and we get 6. So we can actually do that a different way. We can say add stuff 1, 2, and then call that. We can also do this, right? We can do we can sort of fully apply it, or we can even call it with no functions. So with no arguments. So we can do that as many times as we want. What are we going to get from that? We're going to get a function that is waiting for how many arguments? 2 more arguments. So we can say 2, 3. Okay, so just to go through this crazy one here, we've got a function add stuff. We call it with no arguments, we get back a function that's still waiting for 3 arguments. We call it with no arguments, we get a function still waiting for 3 arguments, and so on. And then we finally call it with an argument. We get back a function that's waiting for 2 arguments. And we give the 2 arguments at the same time in that call, and we get 6. Okay. So in a way, currying is super powerful. Now, this syntax here, add stuff 1, 2, 3, looks really weird, right? But it's still valid. And in fact, if we think about the real strict definition of currying, which we looked at before, we can see that this is really like the strict definition of calling a strictly curried function, because we've got to call it once with 1 argument, and then we get back a function, and we call it again with that one with a second argument. We call the result of that one with a 3rd argument, and that's it. Now, we don't need the curry function from Randa to produce a function that actually acts like this. We could say add stuff A produces a function that is expecting an argument B, produces a function that's expecting an argument C, and then once we've got all those together, we can do that. Okay, so we've now defined sort of manually a function that is purely curryable. So we can say now add stuff 1, and that gives us back this bit, which of course is a function that's waiting for a single argument and produces a function that's waiting for a single argument that produces, the evaluation, where are we? The evaluation of A plus B plus C. Okay. So that's fine. I hope we've sort of understood a little bit of the simple part of currying and partial application. I'm going to switch back to TweetDeck and make sure everything's still okay. Yeah, okay. I think that's good. Nobody's screaming and shouting. So I'll move on to part 3. This is the final part. We got a little bit of a wrap up as well. So I think we're still doing okay. So this is a call out to Sudeep, awesome organization, and thank you so much for inviting me, Sudeep. Call out for time. I think we're still good for time. I'm planning to finish around in less than 15 minutes, between 10 and 15 minutes. In my time, 5:45 a.m. So now we've sort of seen currying simple currying in action. Let's get back to the original problem and try to make the filter mechanism a little bit less brittle, a little bit more easy to change, okay, using the concepts of currying, using the concepts of partial application, and using the concept of point-free coding. So let's remind ourselves of what we've got. We've got these products here. And just for the sake of interest, let's pick another product. So we've got these products here, and we've got a product down here called Ikura. I'm only picking that one because it's a single word, it's easier to type. And that product is in category 8. I don't even know what that is, but it's category 8. But the key thing is for us, for this demo, there's another couple of products in category 8. Okay, so we can find them. So the Konbu, still don't know what that is either. And Carnarvon, that's Carnarvon biscuits. Oh no, Carnarvon tigers. Now, I have no idea what they are. Carnarvon is a place in Wales, just down the road from me, really. But anyway, Carnarvon tigers, don't know what it is, but it's a product that's in category ID 8, and that'll do for us very nicely. Thank you very much. So, why don't we call out another sort of leader product style thing? Let's call it Ikura. Ikura. What was it? Tier products. Ikura was the 9th. So Ikura equals, let's go up here, products 9. Yes, there we go. There's Ikura and its category ID 8. Lovely. Okay. Now, if you think about it, what we're trying to do with this sort of filtering and comparison of supplier ID or category ID or any other sort of property that's sort of comparable in a more real world example, what we're trying to do is basically express this sort of thing. I'm going to make it slightly bigger. Express this sort of thing given the name of a property, supplier ID, category ID, and given like a reference product, and also given X thing, a product under test, this product or that product or that product. Does this product compare to the reference product or not? What we want to do is we want to see if the value of that particular property of the reference product is the same. Sorry, the value of that particular property of the property under test, X, is the same as the value of the property of the reference property. Okay, so we've sort of expressed that sentence in a nice sort of concise way, but really strangely and sort of beautifully, that's valid JavaScript. We've defined a function. We've defined an anonymous function. We can't really use it as it stands because we've not assigned it to anything. So why don't we assign it to a variable? Yeah, use the power of JavaScript, treating functions as first-class citizens, as any good language should. So why don't we assign it? And let's call it has same. Okay, so let's just stare at that a minute. This is a function called has same that takes in total 3 arguments: a property, the name of a property, supplier ID or category ID or whatever, a reference product, and a product under test. Okay, and it will compare to see whether the values of that property is the same for the reference product and the product under test. So we can now try that out. We can say, for example, well, actually, before trying that out, what we'll do is we'll curry it. Okay. Actually, no, let's try it out. Let's try it. This has same property, category ID. The reference property is Ikura, and products, I have no idea. Product 1, false. Product 1 is not in supply. I think T products, it's only product number 12, Konbu, and product number 17, Carnarvon Tigers or whatever it is. So if we try that for product 12, we get true. Okay, so that's great. But let's curry that function. So what we'll do instead is we'll say has same. We'll go down here. Oops. What's going on here? Our curry. Oh, sorry. What am I doing? Where's our has same? There we go. Has same. Sorry, there it is. I'm typing without even looking what I'm doing. It's silly. R.curry. There we go. We're currying that function definition. Okay, we're assigning it to has same, so it's the same sort of thing. But now we know about currying. What we've done here is we've defined this function as a function that can take fewer than all of the arguments if we want to. And we know what partial application is. So now let's partially apply this has same function to create another to create a little building block that we can then use in the filter function. So we can say, for example, same category as Ikura, okay, is category ID Ikura. It's almost like English, right? So we're now calling the has same function, but we're partially applying it. We're only supplying 2 out of the 3 arguments. So the result of partially applying has same is, of course, as we know now, not like an evaluated answer, but a function that's still waiting for the final argument, which is going to be, of course, this one, the product under test in this case. So now we can say same category as Ikura for products 12. Oops, products 12. Yes, that's that conbu. Product 13, that wasn't. Product 14, that wasn't. Okay, great. So now we've got a little building block. Okay, same cat as Ikura that we've constructed by partially applying a curried function. That's almost like this factory type thing. So now we can say, let's show products.filter same cat as Ikura. Okay, so now we're using the power of partial application and currying and able to program using the Pointfree programming paradigm, because we're not supplying any arguments here, are we? And in fact, that does exactly what we want, which is to show us the products with the same category as Ikura. So we've got Ikura, Konbu, and Carnarvon Tigers. So that's pretty much it. I mean, this session is only half an hour long, but I just wanted to wrap up by sort of explaining something that we haven't actually mentioned before. And this is sort of part of the power of why this works. And that is the concept of closures. So some of you may have heard the term closure before, and this is closure with an S, C-L-O-S-U-R-E, not C-L-O-J-U-R-E, which is a language, a beautiful language, by the way, a Lisp-based language. And it's also not, there's also a closure from Google, which is a JavaScript compiler, but a closure in this case, in this context, is a concept that is relating to what happens when you produce functions in JavaScript. And I've got a definition here. I've brought MDN up. I've got a definition. A closure is the combination of a function bundled together, enclosed, with references to its surrounding state, the lexical environment. In other words, a closure gives you access to an outer function's scope from an inner function. And that's exactly what's happening here. So if we look at this call, for example, same cat as Ikura, okay, that function, same cat as Ikura, is a function waiting for an argument, x in this case, but that function has access to the lexical scope of the call that we made to has same, which means that it's got access baked inside of the same cat as Ikura function are the values category ID and the Ikura map. Okay, so same cat as Ikura is a function we can carry around, and inside it, it's got the lexical scope of what was around it when it was created into the world, which includes category ID and Ikura. I mean, we could actually, just as a final thing, we could actually redefine has same. Let's just see our definition of has same. There it is there. We could redefine has same using that same standard JavaScript syntax without the r.curry like this. Has same is something that expects a property. I'm not going to put brackets around it this time. You don't need bracket if there's more than one argument. That's expecting a property that produces a function that's expecting a reference product that produces a function that's expecting a product under test that evaluates into prop. That's the same definition. Where is it? There we go, has same. But what we've got to do, of course, because of this strict currying, we've got to call it that sort of weird way by passing one argument at a time. So we can see when we look at the definition of has same in this style, we can see that this is the lexical scope that existed when this function was produced and returned. Right. I think that's it. That's all the time I've got. So thank you so much for having me. I hope you found this interesting, found it useful. I'm going to switch back to TweetDeck and have a great rest of the day. Thanks to Sudeep for organizing and everybody else who's been helping in, like Napit and so on. You folks are awesome. So I'm going to finish the live stream here and maybe go back to bed. Have a great day and see you online soon. Thank you.